Yeah, usually it's hard to manage multiple screens at the same time, especially when you go live. You're not sure if it is working or not. So I have to double check a couple of screens here and make sure that it's working as expected.
Yeah, sure.
Okay. So I guess we're live now. So welcome everyone for our weekly live stream on Twitch. And essentially what we want to discuss today is the Hazelcast resilient to Kubernetes node and zone failures. So joining me today, Sergii Bishyr, one of our engineers. Welcome, Sergii. How's it going?
Thank you. I'm great. Thank you.
So before we start, maybe like a little bit of introduction about, what do you do at Hazelcast and your experience with Hazelcast, then you can start presentation.
Yeah, of course. So I'm working in the cloud native team in the Hazelcast. So what we are doing, we are basically making sure that Hazelcast is cloud native. So one of our main product is Hazelcast's platform operator, which is, well, the name is self-explanatory. So this is a Kubernetes operator for Hazelcast platform, where we are trying to improve the user experience with working with Hazelcast on Kubernetes. It allows users to run Hazelcast easier with more simpler configuration, keeping in mind all the complexity of Kubernetes and Hazelcast as well. Yeah, so that's probably main work that we are doing in the cloud native team.
Yeah, I guess this is really important. So before I hand it over to you, if anyone has any question, feel free to leave your question in the comment section below on Twitch. Otherwise, we're available on our community Slack. So if you have any question, make sure to sign up and join our community. So with that, I'll hand it over to you, Sergii.
Yeah, thank you. So let me share my screen now. Okay, so I think we can start. Yeah, so my name is Sergei. So today we are going to talk about Hazelcast and its resiliency for node and zone failures on the Kubernetes, as Fawaz already mentioned. So let's talk first about the data, because the data is probably the most important part of every application. So that's why we want to keep it safe, and we don't want to lose it. So for not losing it, we have to persist it somewhere on some persistent disk or something. But if we are going to use a traditional database, we will use the benefits of in-memory storages, which will allow you for quicker access. And one simple thing that you could do with your data, not to lose it, is the backups. So if you have multiple members, every partition of your data could be backupped to another member. So in case of one member failure, it will be possible to restore all of your data from the backup. So for example, in this case, if member 3 failures, you can see that we have the backups of the same partitions on other members, and we can easily restore this. But things got more interesting with the Kubernetes, because in the Kubernetes, we have nodes, and one Kubernetes node could contain more than one member. If we have the same setup with 3 members, with data partitions and the backup of this data, but what happens if one node fails? It means that all the members that were running on this node will also fail. And in this case, it will be not possible to restore all of the data that we have here, because as we saw, the member 1 and member 3 failed. And we have only the backup of member 3 because it was stored on another node. Yeah, so we could restore the data partially, but we lost all the data that was stored on the member 1. Yeah, so now let's see what we can do in this case. In this case, we could, first of all, instruct the Kubernetes that we should run all of the members on separate nodes. In this case, we will make sure that it will have all the data partitions stored on different nodes. So if any node crashes, then we can still restore our data. But if you want to have more members than we have nodes, in this case, we have also to instruct Hazelcast to store different the backups of every member on a different node. So in this case, if something fails, then we are sure that from the other node we can restore it. I think it's easier to see it in practice. So let me go here. I have a Kubernetes cluster with 4 nodes. Here at the bottom, you can see we have 4 nodes. Yeah, and first let me install using Helm just a simple Kubernetes cluster. And I will use, since I have 4 nodes, I will use 8 members. Install, let's name it HC Hazelcast. Yeah. So the values YAML for now, it is simple. It just have the member count of 8. Yeah, so it is installed. Let's see that our member is getting created. Okay, so we will have to wait a bit while it's being created. And I will explain my scenario. So I want to show you what happens when one of the node crashes. So for this, I will create a map with 1000 keys in it. And then I will try to emulate the crash of one node. Okay, so let's see what's happening here. This one is running. Yeah, so it will take some time. And after this, we will see that after the restore of the this node and the containers that were running on this node, the members, we will see that we might lose some data. Okay, so let me. Okay. I will need to port forward the connection to my member. Pods. Yeah, it takes some time to set up the cluster of 8 members. So we will have to wait a bit. And meanwhile, I have just a simple Go application that will create a map and will put the 1000 keys into this map. So when the cluster will get created, we can run this script. So still have to wait a bit. And after this, I will show you the same scenario, probably while it's getting created. I will show you the same scenario with the more advanced setup. So in this case, we will apply a new configuration. This configuration will make sure, first of all, that with the Kubernetes topology spread constraint directive, we will make sure that every node will be, every member will be spread equally across multiple nodes. So in this case, if we will have 8 nodes, 8 members, and 4 nodes, each node will have 2 members. And the other configuration, which is partitioning group type node aware, this is the Hazelcast configuration. We will tell Hazelcast that we want to store backup on a different node. So each backup will be stored not on the same node where it's located. So if the member 1 is located on the node A, it will store the backup on any other node but A. Okay, so let's see what the state of our cluster. It's still not up. So it takes some time. So 2 more members, and then we can run our demo to see what will happen. So the nodes are all ready, so we can see that, for example, in this case, there is no any preferences on which node to install the members. So they are all getting installed on whichever member is available here. So yeah, these are the nodes here on which the pod are installed. And in a while, we will get the last one running. Okay, containers creating, running. Let's wait when it's ready. Let's see again on which node it got installed. Yeah, so you see, still not ready. So let's wait a bit. Yeah, now it's ready. Okay, so finally we can run our demo. So I will just run this simple application. Yes, so it installed everything, and we can see in the logs here that map size 1000. Now let's emulate the failure of one node. So I have a simple script that does this. So let's select one random node. I don't know, for example, the second one. So it will install this. And after some time, we will see that this node, which we decided to drop, it will be in the not ready state. Yeah, so this is a chaos experiment that emulates the Kubernetes node failure. And the pods that are located in or in this node should also lose all the data, and hopefully their backup was stored on probably on the same node or maybe on different. If we are lucky and it was on different, then we won't lose any data. But if it was stored on the same node, then we will lose the data. Yeah, so we can see that the node is not ready. And after 30 seconds, the node will get ready again, and we will see that the pod will get recreated. Let's watch the state of the pods. So they are all still running. However, since this is just an emulation, we won't notice that the pods are getting failed, but still it will get recreated when the node is ready again. So let's get back and see what will happen in this case. So in this case, the nodes which were located, the members which were located on the node that we dropped will get killed. So for example, in this case, it might be member 1 and member 4, and we will lose all the data on this. So we will have to get the backup from other members if the backups are available. Okay, so yeah, so we can see that now there's only 3 nodes available here. And we should get it, the 4th node back. So let's try to see what will happen if we connect to the cluster and read the map size. Yeah, so we can see that the map size is not 1000 anymore. So, okay, and the two members which were located on this node are getting created, and we have one to start here. So when it will be ready again, it'll take some time. It should try to back up data if it is available. Now let's apply this configuration with the node aware group type and with the topology spread constraint, which will guarantee our node failure mechanism. Okay, so let me first uninstall the previous configuration. Okay. It is getting terminated. And let's put it with like this. Okay, so now it's terminated. Now let's install the node failure resiliency configuration and see the same scenario. So node values. Okay, it's being installed. Okay, so let's go further to our presentation to not to wait so much because as you can see, it takes some time to run the cluster of 8 members. So let's see what will happen in the next setup that we might have. So with the Kubernetes, we might have also to guarantee more resiliency for our application. We want to might want to have multiple zones. So in this case, we have a cluster with 2 zones. This is exactly my setup, which I will show you later on. And it might happen that the whole availability zone might fail. So in this case, we might lose all the members that are located in these zones and all the nodes that are located in this zone. So we will, again, need to restore the data from the backups. So if we are storing the nodes, if we are spreading the members equally on different zones, and if we are storing the backups in different zones, then again, we could restore this backup. But in this case, as you can see, we cannot do so. So we need to store the right backup. So backup, for example, of member 2 on member 3, which is located in a different zone, and backup for member from member 4 to the member 1, which is also located in different zone. Okay, let's first see the previous scenario. So the container is still being created. Still takes some time. Let me. Yes, so we will have to wait a bit. But meanwhile, let me show the configuration for the previous scenario. So the configuration looks very similar. So we also have topology spread constraint, but in this case, we are using a different topology key. So we are using topology Kubernetes IO zone key, which will set up the nodes for different zones. So let me show you. Show labels. So as you can see, we have 4 nodes and it has different zones. So there is Europe West 1B and there is Europe West 1C. So we have 4 nodes. 2 nodes are located in zone B and 2 nodes are located in zone C. We can also see it from a different node name. So we have here the node pool and with the ID. Okay, let me see what is happening with our pods. Meanwhile, okay, so 5 members are started. And the other configuration difference is the group type. This time it's not node aware, but rather it is zone aware. So yeah, as you can see, here we had node aware, here we have zone aware. And also I have only 4 member counts because this is enough for my setup and for my demo, but this is not important. You can still have 8 members or any number which is multiple of your node number, because this is required to guarantee you that the backups will be equally distributed again on different zones or on different nodes. Okay, so the last member is starting. And then I can show you this setup. Okay. Just a few seconds and it should be ready. Okay, now it's ready. So again, we can, yeah, sorry, I forgot to add this one. Map size now is 0. Let me run my application, which will add 1000 keys to the map. And now let's emulate the node failure again. Let's drop this time this one, the first node. So you can see, first of all, that this one, that we have the nodes equally distributed again on the different nodes. So Hazelcast 0 and Hazelcast 4 is located on the node QDP 6. 1 and 5 is located on this node. 2 and 6 is located on our third node, and on the fourth node is located another 2 members. So we can see that we have equal distribution of the Hazelcast members among our nodes. Meanwhile, we can see that our node which we dropped is not ready, which means that as well our members won't be accessible. So if we will try to connect to it, most probably, yeah, we can see that we cannot connect to it because this member is located exactly on the node that we are emulating the failure of. Okay, maybe we can try this one. Yeah, so we can see we connected to it. So let's start this 0. And now let's watch our nodes. Our members, because soon this node will get ready and our members should get recreated. We are expecting for members 0 and 4 to get recreated when this node is ready. Okay, yeah, so we can see member 4 has 1 restart and member 0 has 1 restart and container creating. Okay, so it will take a few seconds. So I can probably put forward this one already. Okay. It might take a bit longer because we are expecting also the backup process. So the pods are running. Now we're expecting when it's ready, when the startup finishes. Still not ready.
So I have a few questions here in the chat. If you
Yeah, sure. That's a great time to ask questions while we're waiting.
Sure. So the question is, could you use pod management policy as parallel to speed up the cluster startup?
Yeah, and now I'm thinking, why didn't I use it for this demo? But yeah, that will be a great usage of it, because then the pods will start simultaneously, not one by one. So yes, you can use it, and I will also show today the operator demo, and in the operator we are using it, and we will see that the cluster startup time is much faster with this policy.
Okay, good. And can you explain the port forwarding, please?
Yeah, so this is just a Kubernetes thing for testing. So what I'm doing, I am port forwarding from my local to the Hazelcast pod directly. So in this case, I'm port forwarding on the same port, which is the default Hazelcast port. And doing so, I can access this member directly from my local host. So as you can see in my application here, I don't set up any IP address or something. That's why that is because it connects us to my local host, and it can find the member here on the 5701. But this is just for debug. So this is not the production feature of Kubernetes, so it's not recommended to use it in production. But for the debugging, yeah,
Okay, good.
that's what is, yeah.
Yeah, and what does the node-stop.sh do?
This one?
Yes.
So this is my script. Yeah, so what it does, it creates chaos experiment. We are using chaos mesh. We also use it for our testing purposes. So to do our chaos engineering. So it emulates, it creates this experiment, which emulates the node failure in our cases. So yeah, this is not something that we developed. We are just using chaos mesh. But this guarantees us a good testing of some unexpected scenarios as a node failure or zone failures. So I can show you what it does. Sage. So yeah, it's just my random, my custom script, but it creates this YAML file for the Kubernetes chaos mesh.
Okay, thank you. I think these are the questions here.
Okay, yeah, thanks for the questions. Yeah, so meanwhile, our pods are ready, and we can run the application. Why? It's ready. Oh, okay, so the fourth one is ready. The first one isn't. Yeah, so I should have definitely used the parallel. Okay. Let me restart the port forwarding. And now let's connect. Yeah, so we can see the map size is 1000. Okay, so now let me uninstall my setup so that I can show you the zone failures. So let's remind a bit what we have seen, because we had to wait a bit for this setup. So yeah, the configuration, as I mentioned, is pretty similar, only that this time we will guarantee that our pods will be spread against the nodes using this topology key for topology spread constraint. And we will tell Hazelcast to use to store the backups on a different zones by using partition group type zone aware. Yeah, so okay, it's not there. This time I have only 4 members, which is easier because we will have to wait not that long. Okay. And while we are waiting, I have a similar script, which is zone stop. It will also emulate the zone failure. So in this case, whichever zone we will choose, it will drop all the nodes on in that zone. So in this case, since we have 2 zones, we might drop either these 2 nodes or these 2 nodes. And consequently, all the members that are located on these nodes, so it should be 2 members, they will also get restarted and will lose all its data. But since, let's go back to the presentation, since we set up it to, first of all, spread it equally among zones and to store the backups on a different zone, the Hazelcast will restore all of its data, all of its partitions, so we won't lose any data. Okay, so yeah, so we are still waiting for it. So maybe if there are any additional questions, again, while we are waiting, we could ask. So
Yeah, one more question. So I think
yeah, sure.
so the question is, do we support topology spread only in Helm chart, or are there any plan to add to operator someday?
So we have this feature, but in operator, but we are not exposing it. So okay, let me show you how it looks. I wanted to wait it until we show this zone aware, but let's go to the operator part. So for the operator, we could achieve the same basic setup. So we have to create the Hazelcast CR, but we don't need to specify the zone aware and node aware as well as topology spread constraints separately. So all we have to do is set up the high availability mode. So this configuration is simpler because we only have one field, and we just are telling the operator whichever have availability mode we want to use, node or zone. Depending on this, if we set up node availability, then it will set up the topology spread constraint as well as the partitioning grouping, and for the zone as well for the zone. So we support this feature, but it's simplified, so we are not exposing the topology spread constraint directly here. So we just have the high availability mode.
Great, thanks, Sergii. You wanna carry on or more question?
Yeah, there are still 2 members that we are waiting starting. So if there are questions, we still have time.
Okay, so the question is, could we use hot backup persistent to avoid losing data in case of a zone node failure?
Yeah, so for the hot backup, it's a bit different. So because with the operator, for example, we support external hot backup. So to avoid losing your snapshots, you might store it somewhere on the S3 bucket or on the other external storage. So if you want to guarantee that it will be stored somewhere, not just in the persistent volume claim in the Kubernetes, then you can use operator feature, which is external hot backup.
Okay, that's good. I think these are the questions now. If you wanna carry on, or maybe
Yeah,
yep, go on.
yeah, sure. We still have time because it takes a while to start the members. Yes, so I should have definitely used the parallel pod management, but yeah.
Yeah.
Uh,
This is like, you know, when you do live demo, it's kind of like, you know, you don't know exactly what is the best setup. So I think it's good.
yeah. Yeah, so okay, so the last member is running, so now we don't have to wait that much. Meanwhile, we can see that we are spreading our members on still. For example, here it's the different, not the different, but these 2 nodes are the same. But we are guaranteeing that our members are stored in different zones. So we can see it by this ID of the node pool. So as you can see with the topology spread constraint set up to the zone label, we might still store the members in the same node, but we guarantee that it's in the different zones. So because we want to guarantee the resiliency for the availability zone failures. So let me see what is okay. So we have our member running. We can run the application. I hope okay, I didn't do the port forwarding. Okay, so our map size is 1000. And now let me emulate the zone failures. So again, we can choose whichever zone we want. So it changes nothing because it's the same. So we can see that here now we created 2 chaos experiments for a different nodes. So this one and this one, which means these 2 nodes will get dropped, and consequently the members that are located on either of these nodes. So in this case, this should be whichever is it. This is member 1 and member 2 will also get dropped. So yeah, we can see it is not ready now, and with not ready, after some time, after 30 seconds, it will get back again, and we will have 2 members recreated, and the data which was located on this member should be backed up from the other ones, because the backups, we are guaranteeing that the backups are located on the other availability zone. Okay, so we can watch. And again, we have some times from the questions, if you have any. Yeah, because it takes some time from this experiment to run, and also for the members to restart and to restore the backup data.
Yeah, I mean, I got a question here from someone who's asking about the multi-zone high availability, please.
Yeah, but what is exactly the question?
So just to explain the concept, how does it work on Kubernetes?
Oh, okay. Yeah, so first of all, we are setting up this topology spread constraint, which it uses this topology key. So how it works, it guarantees, let me show you the nodes. So each node has a different labels. There's a lot of them, but all the nodes have this topology Kubernetes IO zone. So if we are searching for it, yes, so we can see that we have this. Here it was only 3 nodes because one of them got dropped. So the value of this label is considered, if it's the same for 2 nodes, it is considered in the same availability zone. So as you can see, these 2 nodes are located in the same availability zone because the value of this label is Europe West 1C. And well, that's true. They are located in the same zone. And Kubernetes knows that whichever pod we are deploying, here we could also specify that we want to count only pods with this label selector. We should guarantee that they are spread equally among these nodes with this within different zones. So if we had 3 zones, then we should guarantee that we are spreading it equally among 3 zones or 4 zones or whichever number you have. This is the Kubernetes concept. And for the Hazelcast, we are also setting up this parameter zone aware. And we are telling Hazelcast to store the backups on the different zones. So if the member 1 is located on the zone A, it will guarantee that its backup is stored on the different zone. It could be B, it could be C, whichever zone you have, but just for sure not on the same zone. So this is 2 setup that we have, and this guarantees us the resiliency against availability zone failures. So let's see what's with our members. So the second member, yeah, so they are already getting restarted. Let's watch them. Yeah, so I hope that I answered your question.
Yeah.
But yeah, so the concept is the same for the nodes, because here instead of zones, we are setting up the host name, which is basically the name of the node. So here we are guaranteeing that it is spread equally among the nodes. Yeah, and also we can set up max Q. This is the maximum number of discrepancy that we are allowing. So for example, if it was 2, then it could spread not equally, but it could differ on 2 members. In this case, it could differ on 1 member only. We cannot set up at 0 because otherwise the first member won't be able to schedule because other zones don't have members as well. And yeah, there's also other parameters, what to do when it is not possible to satisfy it. We can set up schedule anyway, or we can set up that we don't want to schedule in this case. Yeah, but this is just a Kubernetes setup here. Okay. So what is happening with our members? It is they are still getting ready, so we have to wait it. And meanwhile, I can show you the Hazelcast CR for the operator. So here, as you can see, this is the basic Hazelcast CR that I have. The only thing which is important here is the high availability mode, which is set up to node in my case. And also I have the operator running. So yeah, here is my operator. And when I'm going to create this one, we can see that we will achieve the same configuration with just one parameter for the operator. Let's see what's happening with our members. They're still not ready. Okay, but yeah. Yeah, so this experiment's run a bit too long. Sorry for that. Okay, but maybe I can just show you the how the operator runs because it takes so long. So let me just uninstall it. And let me apply my Hazelcast CR YAML. So first of all, you can see that we are having the resource named Hazelcast. It's in the pending state. And if we are going to look at our pods, we can see that they are started all at the same time because for the operator, the default value is to run them in parallel. Yeah, and we can take a look at the deployment on the stateful set, sorry. And we will see the same configuration here. Okay. Okay. Just a minute. Yes, sorry. So let us look at the config map instead. Yeah, right. Yeah, config map. Yes, sorry. It is in the config map. My Hazelcast. Yeah, get. Did I apply the right one? So it seems strange. Yes, so the formatting is wrong. Okay, anyway, so we can see now that but again, we have the nodes spread equally among the members spread equally among the nodes. And it would set up this configuration as well for the Hazelcast. There's something wrong with my formatting, so I won't be able to show you somehow. Yeah, but in short, the same configuration is applied for our operator for the high availability mode. We can set up node or zone. Yeah, so that's basically all that I have. I wanted to show you. So we've seen today how to apply the high availability for the Hazelcast for the node failures and for the zone failures. And as well, we have seen how using the operator, this configuration is simplified. So just using one parameter, we could achieve the same setup. Yes, so thanks everyone. If you have any additional questions, I would be glad to answer.
Yeah, thanks very much, Sergey. I think this is really useful, one of the most interactive sessions we have. So a couple of questions here more. So basically first question is, what's the max skew value?
Yeah, so this is the allowed not satisfying number of the members. So for example, if we want to spread it equally among the nodes, value 1 means that no more than one node could be unsatisfiable. So since the first node which will be deployed could not unsatisfy this value, and the second one should unsatisfy already. So if we have 2, then it means that this number is equal to 2. So 2 nodes could, like the number 2 could be the most members which are deployed on the same sorry, I'm explaining it a bit not wrong, not correct. So it means that this is the number of the difference between number of members on the node. So 2 more members could be deployed on the same node, or 3 more members. So yeah.
Thank you. And so the question is, why does the Hazelcast have 2 containers, the Hazelcast bots?
Yes, so this is for the operator purpose. So when we are deploying Hazelcast with the operator, we also deploy the sidecar together with it, because the sidecar allows us to do a lot of different to implement a lot of different features. For example, hot backup, which is external hot backup. We, using this sidecar, could deploy it to external storage. Yeah, so this is basically the sidecar which helps us in case of operator, but it is deployed, as you probably notice, only when the operator is deployed.
Okay, good. And the other question is if the operator is less flexible.
Yes, it is. It is less flexible, but this is done on purpose because we wanted to abstract a bit from the complex configuration of the Hazelcast. Because yeah, with the Hazelcast you have a lot of possibilities, but operator serves a purpose to smoother the corners between the complexity of the Hazelcast configuration and the Kubernetes usage. So we are focusing not on the configuration where you can configure every feature, but more on the features. So you could say that I want to use this feature and configure specific feature, and we will do all the underneath configuration of the Hazelcast and of the Kubernetes. So yeah, it is. But this is done on purpose, and our aim, which we are moving to, is to still cover all the features in the Hazelcast.
Yeah, I guess this brings us to the last question, is like, what are the future features that you're working on now?
Yes, there are like a lot of features sorry. We have a lot of features which we are working on. So our backlog is pretty big. We have a lot to cover, but I can say, for example, that one of the features which are going to release soon is TLS support. Yeah, so just follow the next releases and you will see that each release has a lot of features, because that's what we are covering. So for now, it's not in the support stage, it's active development. So every new release brings a lot of new features.
Sure. So thanks very much, Sergey, for your time and for your presentation, as well as Deva. I think this is really very useful for community to know how to use it. So just to mention, there is 1 or 2 blog posts attached or connected to this live stream. If people want to read about it, just head over to the Hazelcast blog so they can have a look at it. And if they have any questions, also they can join the community Slack to ask any question.
Yeah, so I can add that this blog post cover exactly the same, which I explained, except that if you want to try to emulate this node failures and zone failures, you can check out the operator repo. We have the high availability test there, and you can see how it is done. And you can see that we are running it and are testing the operator with the Hazelcast for the high availability as well.
All right. So thanks very much for your time, Sergey. I think this has really been useful session on Twitch. So thanks very much. And thanks for everyone attending a live stream on Twitch. Don't forget to click on follow to join us for next live streams. And next week, also, we will be carrying on the machine learning with Hazelcast. So I'll see you in the next one. And thanks very much, Sergey. Have a good one.
Thanks, everyone. See you. Bye-bye.